Okay, one more time, one more here on the kind of review, but new. I know my volume cut out on the last time when I did a matched pairs problem. So, oops. Oh, it's not going to let me right up there. There we go. A matched pairs problem. So, um, I'll try to teach and do this example at the same time. So, we've got gasoline. Some people run regular gas, some people run premium gas. The regular gas is a lower octane, and that's usually about 87 on the pump. The premium is a higher octane. It's 92. It used to be called ethyl gas back in the day when we had leaded gas. They'd say filled up with ethyl. That was the premium. Just a little trivia for you. Someday we're on Jeopardy or whatever. I don't know. Okay, these certain engines are designed to run on higher octane gas. My boat, for instance, they specify from the manufacturer run 89 octane or more because that's how it's designed to run. It has to do with timing and some other things like that on the engine. Well, people think that, man, if I run 92 octane on my car, that the manufacturer says run 87, they think one, it's going to run better, and two, it might get better mileage. Both of those are actually false, but we tend to think that, and premium gas is way more expensive than regular gas. Okay, so it all depends on how your engine is put together and how it's adjusted as to whether premium makes a difference. But again, people don't know that, and so they decided, hey, let's do a test here and see. So they used 10 cars from a company fleet. Each card is filled with regular or premium, decided by a coin toss. The mileage for that tank full is recorded, then the mileage recorded for the same car on the other tank. Okay, the drivers don't know about this experiment, so they can't be influenced how much they step on the gas or use a brake or don't use a brake or whatever. Okay, so for the first car, it got 16 miles to the gallon on the regular tank and 19 on the premium, and so forth. Okay, so the question is there evidence that cars get significantly better fuel economy with premium? Okay, well, let's do this. Well, actually, let me ask you this. How many samples do I have? Do I have two samples? Well, definitely. I've got miles per gallon for the regular gas, and I've got miles per gallon for the premium. So those are my two samples. So I could say mu R is the average MPG for regular gas, and mu P is the average miles per gallon for the premium gas. Okay, and if I was going to do this, I could do a two sample test, right? And I would say H0 mu R equals mu P, and HA I would say mu R, because I want to know if the premium is less than mu P. All right, does that make sense? Okay, if we did the conditions, what is the last condition that we have? The last condition is that the samples are independent of each other. Okay, what are these two samples independent of each other? In other words, does one sample have nothing, absolutely nothing to do with the other sample? And the answer is no, they're not independent, right? This sample here most certainly affects this sample here, right? Because they're the same cars, right? It's the same 10 cars for each one. Okay, so I kind of think of it as if this one gets crummy gas mileage, this one's going to get crummy gas mileage as well, or better gas mileage or whatever. It's the same person driving the car, okay? So they're going to have the same, however that person drives will affect them both the same. So there could be a relationship between these two samples, okay? So this is not true. So if they're not independent, I cannot do a two sample test. So none of this is valid, okay? Again, because my samples are not independent of each other. One sample certainly can and does affect the other sample, Okay, again, because it's the same people driving the same cars. Um, it's the same cars. It's all of that. Okay, so the question is, then what do I do? Okay, can we do anything like this? Well, what we do is we look at this. Like my poor dog's outside going, let me in, let me in. Um, let's look at the difference between premium, because it looks like the numbers on premium are maybe a little higher than the numbers on regular. I don't know. I'm going to look at P minus R and subtract them. 2, 3, 2, 2, 3, negative 1, 1, 1, 4. Okay, these differences, okay, these are called differences, and it's P minus R. Now those differences are one. That's one sample, isn't it? This number represents the difference in miles per gallon for the first car, the difference for the second car, the difference for the third car. Okay, this now becomes a one sample test. Okay, and let's look at mu. We'll call mu sub d. We're going to call that the average difference miles per gallon. And we can even do like premium minus regular. Okay, so I can talk about the average difference between them, and I can even do this, mu sub d equals 0. What does this mean? This means that the average difference is 0. This means there is no difference between regular and premium and PG. Okay, and then HA, mu sub d is, I want to know, do I have evidence that the premium is better? Well, if the premium is better, then my difference should be bigger than 0, right? This tells me that the premium is better MPG than the regular. Okay, so does that make sense? We went from two samples that are related to each other to one sample. Well, since there's one sample, I don't remember about anything being related to each other. Each of the individual data is independent, because this first piece of data doesn't affect the second piece and so forth. But now I've got a one sample test, and my one sample are the differences. And I'm going to assume the average difference is 0. There's no difference between that's equal to 0, which means there's no difference. Or I'm going to see, do I have evidence that it's actually greater than 0? This is like a normal test where I just said mu equals 10, mu is greater than 10. It's the same test, except now, instead of using 10, we're just using 0, kind of thing. Okay, so let's do this test now. What kind of test is this? This is a one sample t-test, but we want to identify it that it's paired, because my data is paired together. That's why I don't use a two sample test, because that data is a pair, that data is a pair, and so forth. Okay, all right, so we've got a one sample t-test. Now the good news is this test is just like a normal one sample test. Okay, I've got my hypothesis, name of test. I'm going to do my conditions. My conditions are the samples are random. We're going to assume that they're random. Okay. Secondly, we have to have that the samples are paired. Number 3, let's see, 10 is less than or equal to 10% of the population. And number 4, 10 is less than 30. Let's see, we can say is the population, so that doesn't work. So population approximately normal. I don't, miles per gallon, is that approximately normal? Actually, you might be able to argue that but I've got some gas hogs down here, the middle of the road, and then we've got some cars that get great gas mileage. I think that's a reasonable assumption. Okay. And now I can go ahead and go to my calculator and do my normal one sample t-test. So I'm going to go test, stat, t-test. mu0 is 0. X bar, oh, I didn't calculate my X bar standard deviation. You know what I'm going to do? I'm going to put those in my list and do it that way. So that you can hear my keys going like 10 times faster than you guys text. Holy smokes. Okay, so I'm going to go stat, t-test, and now on my t-test, I'm going to put data in there. And it says mu0 is 0. My list is L1, frequency is 1. And I want to know, is it greater than mu0? Okay, so if I do that, I get t equals 4.47. The p-value equals 7.7 times 10 to the negative fourth, which is approximately 0. Holy cow, see, this contradicts what I said earlier. And I really don't believe this is true, but based on this data, it looks like it's true. Or there's certainly evidence for it. We're not proving anything, right? So since 0 is less than 5%, I have strong evidence that mu sub d is greater than 0. In other words, the mean difference, not the difference of the means, but the mean difference between MPG, using premium and regular is positive, right? Or that premium users get better gas mileage, MPG, than regular users. I think I know from, just from knowing cars, I do a lot of reading on this stuff. That's not the case. So what might be the reason for that? It might be that we have a small sample, and this might be a bad assumption right there. Okay, but based on what we have, we're going to go with this result. Okay, don't bring in your personal things like I just did on a test. You never do that. You just go with what's given to you. All right, there we go.